Morning, students. So we're going to continue with the Lewis structure lab. And so for the second part, we are looking at the dichloro monoxide, and that's the OCl2. So on step one, what we need to do is we need to find the valence electrons in the molecule. So to be able to do that, I made this chart so that I can keep track of how many are in each of the different atoms. So I am first going to look at oxygen and find how many valence electrons there are. And so I really like following the trend of using the columns. So I'm just going to number these so that I can keep track of how many valence electrons there are. So, and I number these so that I can follow the trend of how many valence electrons are in these groups. So looking at oxygen, it's in the sixth column, which means it's going to have 6 valence electrons. So I'm going to write that over here and to keep track of it. And then for Cl, we can tell that it is in the 7th column right here. So it's going to have those 7 valence electrons. Okay, great. So to be able to find out how many there are, I'm going to do 6 plus 7. Oops, 7. However, we do have to take into account that we have 2 chlorine atoms. And so we're just going to times that by 2. Okay? And so our total valence electrons are going to be 20. 20 total valence electrons. Okay, so with that, we're going to go to step 2. So step 2, we need to figure out the connectivity of our molecules. So we need to know, is O going to be in the middle or is Cl going to be in the middle? So looking at our electronegativity trend, oxygen and chlorine are both very close. So it's going to be these two values. However, as you can see, the chlorine is actually less than oxygen. However, there is a second trend that we need to think about, which is which atom can make more bonds. And so Cl only has 7 valence electrons, so it wants to gain 1. So it's typically not going to be in the middle because it can only make 1 bond. Whereas in oxygen, since it has 6 valence electrons, it wants to make 2 bonds. So it's more likely to be in the middle. Okay, we're going to try that out. So OCl. And in step 3, what we're going to do is we're just going to make those bonds between them. And so that's going to be our skeletal structure, is what our book calls it in Chem 1010. Okay, and I really like to be able to keep track of how many electrons I have. So I'm going to put the total, which was 20. And then we used 4 electrons to make bonds. So 2, 4. So now how many we have left over is going to be those 16. So in step 4, what we're going to do is we're going to be putting lone pair of electrons in the in the external atoms. So we're going to put them on Cl. Okay, and we're going to put enough for us to complete the octets. So I'm going to be putting 6 around each of them. Okay, and then we're going to double check. So I have 2, 4, 6, 8 electrons on Cl. And over here I have 2, 4, 6, 8 electrons around Cl. So those ones are good. And again, I like to keep track of my electrons, so I just used 12. 12 electrons used in lone pairs of electrons. And then, so what I have left is I have 4 electrons left. And so this is going to be put onto the central atom. So 1, 2, 3, 4. We're going to check and see if this now has a full octet. So on oxygen, we have 2, 4, 6, 8. So that's going to be a full octet. So this is going to be our final Lewis structure. I hope I spelled that right. Okay. And now the next step is going to be using this to be able to find out what the geometry is of the molecule. So the best way I've seen is the table that we have on the procedure is actually really good. So we're going to first determine how many electron groups are around oxygen, as that is the central atom. And then using that, we'll find the electronic geometry. So over here, we have 1 electron group, 2, 3, and 4. Okay, so we have 4 electron groups. So 1, 2, 3, 4. Okay, so if we look over here, this has number of electron sets, which I'd set as groups, but same thing. And so we have four, so this is going to be a tetrahedral for our electronic geometry. Now for molecular geometry, this one's going to be a little bit different, and that's because we're going to look at our lone pairs, which is going to change our shape. So over here, if we have two lone pairs, which we do, we have one here and one here, then that's going to give us a bent shape. So I'm going to write that down. So for molecular geometry, we have bent. So the next step in the lab is going to be looking at this in 3D. So what I'm going to do is I'm going to use an app to be able to determine, or to be able to look at the 3D model. And so I like the one called Mold View. So this one's really good. Okay, let's close the pop-ups. So as you can see here, it shows our molecules in 3D so that we can make a 2D shape like 3D. So I'm going to delete this and put in the molecule we have. So we have oxygen and we have two chlorines. So 1, 2, and then I'm going to put a bond in between each of them. Okay, and then I'm going to clean it up with this. Okay, as we can see, this is now going to be our Lewis dot structure, or similar to our Lewis dot structure, just without those electron groups. And the 3D is going to look like this. Okay, and as you can see here, it's bent. Now, if we had those electrons in this, it would be a tetrahedral. But looking at this molecule without the electron groups and just taking into account the atoms, we can tell that it is not a straight line, but it is instead bent. So that's going to be it for our, I forgot the name, the dichlorine monoxide.